He stared down a death sentence and defied all odds.
We used to think that time was eternal.
The propeller's blade's attached to a hub. This piece of aluminum is on its way to becoming that hub. Like the starting pieces for all parts, it was forged beforehand into a rough version of the final shape. This sophisticated computer-guided mill now machines the piece. 40 minutes later, the hub is finished and ready for assembly to the engine. This roughly shaped piece is about to become one of the propeller's blades. A computer-guided lathe machines it to the final shape. Liquid lubricant washes away the metal shavings and cools the friction-generated heat. The lathe first forms the shank, the end of the blade that fits into the hub. The next milling machine cuts the blade's shape. Now the finishing steps, done manually because they require a keen eye. Workers use a rotary sander, then a belt sander to grind away the marks the machining process left behind. They buff the metal with a polishing wheel. Then clean the blades by dipping them in a strong detergent. This acidic solution eats away any dirt, oil, or grease on the surface of the metal. After that, they dip the blades in a bath of water and chromic acid. This seals the pores in the metal, fending off corrosion. The factory tests all critical parts for surface defects by dipping them in a fluorescent solution that leaches into any imperfections. After rinsing, an inspection under black light. A blue glow means the parts are A-OK. Any imperfections show up as bright fluorescent green. The defective part is either repaired or rejected from the production line. Blades that make the cut move on to the paint shop. A coat of black on the backside to prevent sun reflection into the pilot's eyes, and stripes for safety to make the spinning blades visible. Next comes a de-icing boot, a rubber-encased electric heating element that prevents ice buildup. The rubber is highly durable, yet flexible enough to mold to the curve of the blade. Next, they lubricate a part of the blade shank with grease, then install a strong steel ball bearing system. This will hold the blade securely in the hub, yet still enable it to pivot to change its angle. The shanks of the three blades fit right into this steel part called the fork. It keeps all the blades at the same angle. Now for what's called the pitch change rod. The term pitch refers to the angle of the blades. Engine oil will exert hydraulic pressure on a piston that moves the pitch rod, which advances the fork, rotating the blades to the required angle. After removing the pitch change rod temporarily, they apply sealant to the top half of the hub and place it over the bottom half that contains the ball bearing set. A rubber O-ring seal. Then a sturdy spring to provide the required counter pressure. Workers thread and torque the piston and pitch change rod, now attached to each other, to the fork. Another rubber O-ring, this one to prevent leaks out of the top of the cylinder that'll contain the engine oil. They use a special tool to tightly torque the cylinder down against the hub. With assembly complete, this propeller is ready to be installed on today's airplanes. If you have any comments about the show, or if you'd like to suggest topics